Hello, and welcome to Sleepy Story. Tonight we will drift, quietly and unhurried, toward the farthest edges of what our instruments can hear. The places in the universe where entire cities of stars go quiet, where light thins to a whisper, and where galaxies seem to be present only as a weight on the fabric of space. Before we begin, I would love to know where in the world you are listening from. Are you tucked into a warm bed, a window cracked open to the night air? Are you on a late bus, the landscape sliding by in dark silhouettes? Or maybe you're on a balcony under a soft sky, the faintest stars beginning to appear. Wherever you are, thank you for keeping me company. If these calm late explorations help you rest or spark your curiosity, I gently invite you to like the video and subscribe. It encourages me more than you can imagine, and it keeps these journeys possible. And to everyone who has already watched, listened, subscribed, or simply shared a quiet minute here, thank you. Your presence turns a solitary study into a small constellation of listeners. A small warning, offered with a smile. This story may keep your thoughts wide awake. If that happens, perhaps you will fall asleep later with a head full of galaxies, which is a lovely way to wander into dreams. Close your eyes, if you wish, and picture the familiar view of the night. Constellations hang in their usual places, the Milky Way a soft river of grainy light. Between the bright patterns there is blackness, and within that blackness there are still more stars, too faint for the eye but real. Now pull your attention farther, beyond the foreground of our own galaxy, beyond the scattered glitter of nearby clusters, farther still to where galaxies become simple smudges, to where even smudges thin, to where the background itself seems to hold its breath. The silent galaxies beyond reach is a phrase for that hush, a name for the places where light refuses to arrive in the form we expect. Silence in astronomy is never absolute. Even darkness is a mixture of signals. Dust glowing faintly at long wavelengths, cold hydrogen sighing in the 21-centimeter line, ancient background radiation stretched thin by the expansion of space. But compared to the showier parts of the sky, the starbursts and the luminous spirals and the fireworks of colliding galaxies, there are regions where the universe grows careful and quiet. Some galaxies are so diffuse that their starlight blends with the sky itself. Some are shrouded by dust that hides their young stars. Some have stopped forming new stars and drift as red and quiet islands. Some are not truly dark at all, only shifted so far into the infrared by distance that our older eyes and older telescopes miss them. And some, if our theories are right, are mostly halos of invisible matter with only a sprinkling of stars, like villages built from air around a single lamp. Imagine a telescope dome at midnight, the slit open to a river of cold air. Inside, a small team makes small adjustments. A focus tick here, a guiding tweak there, a muttered timestamp in the red glow of a desk lamp. The sky looks like a simple black sheet, but the detectors do not see sheets. They see a floor of brightness laid down by Earth's atmosphere and by the universe itself. To discover a silent galaxy, you must write a signature that is fainter than that floor and more patient than the noise of electronics and weather. You must measure not just points of light, but the way light smears across the sky in shapes too shallow for the eye to trust. The work is slow, sometimes dull, always careful. And then, sometimes, when data are stacked and cleaned and aligned, a vast ghost appears. A disk so pale that it seems drawn in chalk, big as the Milky Way, but with so few stars per unit area, that night itself almost erases it. These are ultra-diffuse galaxies, enormous in extent, fragile in brightness, survivors of histories we only half understand. Why would a galaxy be quiet? There are many ways to hush a system made of gas, stars, and gravity. A galaxy that passes through the thick air of a cluster can be stripped of its gas by ram pressure, the way wind strips leaves. Without gas, star formation fades, and the lights go out one by one. A galaxy that hosts a central black hole can send energy outward through jets and winds, warming the gas so that it refuses to collapse into new suns. A burst of star formation can burn through a reservoir of fuel quickly, leaving nothing but embers. Or a galaxy can simply fail to gather gas in the first place, trapped in a shallow well of gravity where a few stars are all that ever formed. The result is a population of worlds that do not shout. They persist, but softly. Other kinds of silence come from distance. As space expands, the light from faraway galaxies is stretched. Photons that began in the ultraviolet and blue, born in the fierce cradles of newborn stars, arrive at our instruments as deep red and infrared. For a long time, our eyes were tuned to the wrong color. We were listening to a choir with cotton in our ears. Newer instruments that listen in the infrared have begun to reveal swarms of tiny early galaxies that once hid in the glare of the sky. Their silence was not a refusal, it was a mismatch. We were on the wrong frequency. If you have ever missed a whisper because you stood too far away, you know the feeling. The words are there, but they are thin as spider silk. There is a harder boundary as well, a limit with a philosophical flavor. Because light takes time to travel, the deeper we look, the younger the universe we see. Go far enough, and you reach the era before the first stars turned on, when hydrogen drifted dark. We call that epoch the cosmic dawn, and we hunt its first lights with the patience of gardeners waiting for a season to turn. Beyond that dawn, there is no galaxy light at all, only the afterglow from the hot beginning, stretched so long that it fills the sky as a uniform murmur. And there is an even sterner boundary, a horizon beyond which light will never reach us, no matter how long we wait, because the expansion of space carries those regions away faster than light can close the distance. The phrase "beyond reach" is literal there. Those galaxies, if they exist, are exiled from our future. Their silence is forever. Some silences are semantic. Galaxies speak in light, but they also tug with gravity. A dark galaxy might be a halo of matter that bends and stirs and sculpts, with only a pinch of stars at its heart. We can infer such a structure by the way it lenses the light of more distant things, or by the motions of gas clouds that swirl as if around something heavy but unseen. In such cases, the galaxy is not silent to the fabric of space. It is only silent to our eyes. It is a body speaking in a language we are just learning to hear. When people picture astronomy, they often think of color, a spiral galaxy with bright knots and arms, a nebula like a patchwork quilt. The truth is that much of the frontier is gray. The questions live in low contrast, features as faint as breath on glass. To find meaning in that gray requires a different kind of seeing. You learn to believe in things that emerge only when many nights are stacked, when the world's rotation becomes a metronome in your math, when the ridges and troughs of random noise cancel and a pattern holds steady between them. A silent galaxy is not a loud discovery. It is a consensus reached by careful addition. If all of this sounds technical, let it also sound human. The people who search for quiet galaxies do so with the same mixture of stubbornness and awe that any patient craft demands. They talk softly so as not to distract a colleague's concentration. They print out the faintest of images and draw circles and arrows, not as proof, but as invitations. Look here, at the place where there is almost nothing, and tell me whether you also see a shape. Silence becomes communal, shared across time zones and languages, a puzzle that many eyes hold at once. It is a kind of listening done together, and still, the mind wants story. It asks, what kind of life does a quiet galaxy live? Does it host old red stars moving like slow bees in a cold hive? Are there planets circling those old stars, with skies forever dim, where night and day are nearly the same? Would such places be kinder or harsher than ours? Or science cannot answer that directly, but it can offer an attitude. A quiet galaxy is proof that the universe's creativity includes restraint. Not every region is a festival. Some are libraries, some are monasteries, some are fields left fallow across long winters so that spring elsewhere can bloom. We will spend this series walking through kinds of silence and kinds of reach. We will ask how gas is stripped, how gravity sculpts, how light is shifted, how instruments learn to hear what once they missed. We will trace how a galaxy can be loud in mass and quiet in light. How a galaxy can be near in kilometers and far in difficulty. How a galaxy can be present but unannounced. We will explore techniques that turn whispers into songs. Long exposures, clever filters, radios that listen for hydrogen, mathematical lenses that bend space in equations before it is bent in glass. Tonight, let this be the opening of that walk, a slow beginning lit by the smallest of glows. Before we drift onward, pause with me on an image. Picture a vast, nearly invisible disk suspended in nothing. Across its face move a handful of ancient stars, each dim, each distant from its neighbor, like lanterns set too far apart on a foggy road. Outside, the disk is a halo that weighs much more than the lanterns do, a sleeve of unseen matter that holds the whole together. Somewhere in that halo, a trickle of gas still falls inward, but it is too thin, too warm, or too disturbed to collapse into a fresh cluster of lights. The galaxy breathes out in decades rather than seconds. Its time is slow. Its music is bass notes you feel more than hear. That is one kind of silence. And now another. A small, newborn galaxy at the edge of what our best telescopes can see. Its light left when the universe was young, and on the way that light was stretched as if on a rack, blue to red, red to longer, until only detectors colder than ice could listen. For us, this is silence because we are not built to receive it. It is a private lullaby that we overhear only by inventing new ears. When we do, the lullaby turns out to be a chorus. Far from empty, the early universe is crowded with little fires, too pale for the old tools, perfectly audible to the new. That is another kind of silence, a darkness that was not a lack, only a waiting. The final image for tonight, a patch of sky where nothing much appears, and behind that patch, a galaxy cluster so massive that it bends the paths of photons from even more distant things. In the smeared arcs that result, stretched like taffy around an invisible center, we can sometimes read a story about a galaxy that no camera can resolve directly. Gravity becomes a mirror. The mirror reflects something almost too faint, and we catch it only because the universe itself is helping us, curving light into our open hands. That is a silence with a partner. A galaxy that cannot speak loudly, assisted by space-time. Let this be our beginning. The galaxies that are quiet are not mistakes or afterthoughts. They are expressions of the fullness of what galaxy can mean. In the nights to come, we will step carefully from one room of this museum to the next, from diffuse giants to gas-poor dwarfs, from quenched ellipticals to veiled starbursts, from red horizons to horizons that recede faster than time can chase. We will carry with us the calm taught by long exposures, the sense that some truths arrive when you keep still long enough to let the noise drain away. If you are growing drowsy, let your breathing match that patience. If you are alert, let the questions settle like dust on a shelf, waiting without hurry to be picked up again. We will continue soon, taking our first close look at how a galaxy can be hushed by its surroundings, how crowds can make individuals quiet, and how a journey through a cluster can strip a system down to its dimmest bones. For now, rest with the idea that silence is not absence, but texture. The universe is not only loud with light, it is also carved by rooms where light speaks in whispers. Thank you for listening, for being part of this small circle of night watchers. Your attention is the instrument that makes these distances feel close. Silence is never random. In the universe, every quiet place has a reason. If we listen closely to the galaxies that barely shine, the first explanation whispers from their surroundings. A galaxy is not an island. It lives within tides of gravity, currents of gas, winds as fierce as hurricanes but spread across millions of light years. To understand why a galaxy goes quiet, we must first walk with it through the crowded streets of a galaxy cluster. Picture such a cluster. Thousands of galaxies gathered into a gravitational city. Their motions are fast, hundreds or even thousands of kilometers per second, like cars on intersecting highways. Between them stretches a medium not empty, but filled with hot plasma, glowing in X-rays, thin enough that no human eye could notice, but dense enough on galactic scales to matter. When a spiral galaxy enters this environment, it does not glide smoothly. It is battered. The plasma pushes against its disk like wind against a kite. Gas, the breath of stars, is stripped away. Blue knots of star formation sputter and fade, leaving only red embers. Astronomers call this process ram pressure stripping. To watch it is to see a galaxy's lungs collapse. What remains is a hushed skeleton, stars without renewal, light without song. There are images where this violence is caught mid-gesture. A spiral falling into a cluster trails streams of gas tens of thousands of light years long, like a scarf ripped by speed. In those tails, new stars flicker briefly, lit by the very gas that was torn away. But the core of the galaxy empties, deprived of the raw material of youth. In decades measured cosmically, the spiral becomes smooth and featureless. Its voice, once bright, quiets to a hum. That is one path to silence. Other galaxies fall not into clusters but into groups, smaller, more intimate gatherings where gravity still speaks in stern tones. Here, the silence comes from encounters. Two galaxies pass close, and their mutual tides stir gas and stars alike. Sometimes the stirring ignites starbursts. Other times, it flings gas outward, leaving interiors starved. A galaxy that once bloomed becomes quiescent, like a musician who has played their final note. Groups are laboratories of transformation. To live in them is to be changed, sometimes into brilliance, sometimes into silence. The universe also quiets galaxies with time. A system born in an environment pouring gas may never sing loudly to begin with. Some dwarf galaxies show only faint glows, as if they lived their entire lives in whispers. Their stars are old, their gas long gone, their mass too small to hold on to what little fuel remains. These dwarfs remind us that silence is not always imposed. Sometimes it is native. Just as some lives are gentle from birth to end, some galaxies are born quiet. There is another mechanism of silence, subtle and powerful: feedback. At the heart of many galaxies lies a black hole millions or billions of times the sun's mass. When gas falls inward, it does not simply vanish. It heats, swirls, jets outward, driving winds that can reach across hundreds of thousands of light years. These winds do not destroy stars already formed, but they prevent new ones. They heat gas until it cannot collapse, stirring reservoirs until they disperse. The result is a galaxy that looks calm, but is ruled by an engine of quiet at its center. Feedback transforms hunger into famine. It is silence enforced from within. Astronomers map these processes with many tools. Radio telescopes catch tails of hydrogen stripped away. Optical cameras see blue arcs of young stars born in streaming debris. X-ray observatories reveal the hot plasma that provides the wind. Together, they compose a story. Galaxies are not only silenced by distance or birth, they are silenced by life in community, by interactions that rob them of fuel, by central engines that heat and expel. The cosmos is full of choirs, but choirs sometimes thin to solos, and solos sometimes fade into rests. For us, these stories carry more than technical meaning. They remind us that environment shapes destiny. A galaxy in isolation may sing longer. A galaxy in a crowd may go quiet sooner. So, it is with people. The contexts we inhabit, our communities, our pressures, our collisions, shape the music we can make. The silent galaxies are mirrors, showing us how connection both sustains and silences. They remind us that quiet does not mean absence, only a different mode of being, and silence, once more, is not failure. Even a hushed galaxy contributes mass, gravity, and history. It curves space-time, anchors neighbors, provides metals forged in past stars. Silence is not uselessness, it is legacy. A galaxy that no longer sings is still part of the harmony. Perhaps, for the universe, silence is one of the deepest notes. As we prepare to move on, keep this image. A spiral galaxy rushing into a cluster, its arms streaming like ribbons in a storm, gas torn free to glow faintly behind. Ahead lies its future as a smooth red oval, hushed but not gone. This is how galaxies fall silent among their peers. Next, we will explore the galaxies that go quiet not through environment, but through exhaustion. Systems that simply use up their fuel, and in doing so teach us about limits, cycles, and the poetry of endings. Not every galaxy falls silent because of storms from outside. Some drift towards stillness for a simpler reason. They run out of fuel. Imagine a fire. If wood is not added, flames eventually dwindle, leaving only red embers. A galaxy is not so different. Stars require gas, cool clouds that collapse under gravity into new suns. Without gas, no new light is born. Over billions of years, silence comes not with violence, but with exhaustion. Galaxies are born with reservoirs of hydrogen and helium, primordial elements left from the young universe. In their youth, spirals blaze with blue light. Clouds collapse, clusters ignite, and their disks shimmer with newborn brilliance. But star formation is hungry. Massive stars live fast and die in supernovae, blowing away gas, while low-mass stars lock fuel inside them for billions of years. Each generation depletes the reservoir a little more. Unless fresh gas flows in, from the cosmic web, from mergers with companions, from the slow rain of intergalactic clouds, the reservoir empties. A galaxy without fuel is like a musician with broken strings. The instrument remains, but the melody cannot continue. Astronomers call this transition quenching. A quenched galaxy is not dead. Its stars still shine, but its light is old, red and steady, without the bright blue of youth. Across the universe, vast populations of quenched galaxies exist, especially in clusters but also in isolation. Their quietness tells us something about cycles, about limits, about the poetry of endings. Not everything can grow forever. Sometimes the most natural fate is rest. Consider the great elliptical galaxies. Many are thought to be the result of mergers, spirals colliding and merging, their gas burned or expelled, leaving a smooth oval of ancient stars. These systems are among the largest structures made of starlight, and yet they are among the quietest. Their silence is not from weakness, but from completion. They used their fuel long ago in brilliant bursts, and now they glow like coals that refuse to die. Their light is constant, subdued, and enduring. In their stillness lies dignity. Other galaxies exhaust themselves in starbursts. A sudden inflow of gas triggers a frenzy. Thousands of stars form in short spans of cosmic time. The galaxy flares with ultraviolet light, a beacon across millions of light years. But frenzy has a cost. The gas is consumed. Supernovae blow out what remains, and within a fraction of the galaxy's lifetime, silence descends. Starburst galaxies are fireworks, bright, brief, unforgettable, but destined for quiet afterward. Their silence is the echo after applause. Exhaustion also shapes dwarfs. Small galaxies, shallow in gravity, cannot easily replenish gas. Even modest bouts of star formation drain them. Some dwarfs now contain only the remnants of their first generation of stars. They are fossils, records of ancient times when the universe was young. Looking at them is like holding a relic, not grand, but deeply meaningful. Their silence carries memory. It tells us that even small systems matter, even whispers contribute to the song of the cosmos. Astronomers map exhaustion by studying colors. Galaxies filled with newborn stars shine blue, those quenched glow red. Between them lies the green valley, a population caught in transition, slowly fading. By tracing how many galaxies live in each category, astronomers can reconstruct the rhythms of cosmic history. They learn that the universe itself once sang louder. Billions of years ago, star formation peaked. Since then, it has declined. The cosmos is aging into quietness. To know this is not to despair, but to recognize that even the universe has seasons. For us, there is something tender in this recognition. We too live in cycles of energy and rest. We know what it means to pour ourselves into effort until fuel runs low. We know what it means to rest, to let embers glow without forcing fire. Galaxies remind us that exhaustion is not shameful. It is natural. A galaxy that has stopped forming stars is not lesser. It is simply older, calmer, at peace with its past. Exhaustion is also generous. The stars already born continue to shine, feeding planets with light, seeding elements into future generations. When massive stars die, they scatter carbon, oxygen, iron, the building blocks of life. Even silence leaves gifts. A quiet galaxy is still a cradle, not of new stars, but of memory and matter. Its silence enriches the universe. Imagine yourself looking through a telescope at a red elliptical galaxy. To the eye, it may seem unremarkable, a smooth glow without arms or bursts. But within that glow are billions of ancient stars, each carrying a story older than Earth itself. Their quietness is not emptiness. It is the weight of history. To listen to such a galaxy is to listen to time itself, stretched across billions of years, humming low and steady. So galaxies fall silent not only because of external storms, but because of inner limits. They remind us that rest is part of every journey, that even in stillness, beauty persists, that endings are not always violent. Sometimes they arrive softly, like twilight. As we leave this reflection, hold the image of galaxies glowing like embers, once fierce with fire, now calm with endurance. Their silence is not the end of story, but another chapter. Next, we will explore galaxies whose silence is more elusive still. Those hidden not by exhaustion or stripping, but by veils of dust. Galaxies whose voices are muffled rather than gone. They are not truly silent, only hushed, waiting for us to learn how to listen differently. Dust can quiet a galaxy without stealing a single star. From far away, it may look as if the system has slowed, its voice reduced to a hush. Up close, behind the curtain, the opposite can be true. Thousands of newborn suns flaring within cocoons, their light swallowed, warmed, and resung in colors our eyes do not natively hear. This is the kind of silence that is not an ending, but a transformation. A lullaby translated into another language. Begin with a simple picture, the one most of us carry. A spiral galaxy, bright with clusters, beads of blue along its arms, lanes of darkness threading between. Those dark lanes are not emptiness. They are dust, tiny grains of carbon and silicates forged in the atmospheres of dying stars, mixed with gas, stirred by gravity. Dust is small enough to ride on light and large enough to block it. It turns starlight red, just as a low sun turns the sky to copper. It maps itself across disks like ink in water, blotting here, thinning there, sculpting what we see. When a galaxy tilts edge on, the lanes merge into a river of shadow that seems to cut the disk in two. If you knew only this view, you could mistake fullness for famine, voice for silence. But dust is not merely a thief. It is a musician that plays in another register. Photons lost from the optical are not destroyed. They are absorbed and re-emitted in the infrared. A galaxy that appears quiet in visible light can blaze in wavelengths that human eyes cannot detect. Point an infrared telescope toward a dusty starburst and you will find a furnace, a city of stars under midnight cloud, warming the cloud until it glows like banked coals. Entire classes of galaxies owe their discovery to this effect. Luminous and ultraluminous infrared galaxies with tangled hearts, collisions and mergers wrapped in wool, invisible to the casual glance. Their silence is a misreading, a matter of listening through the wrong instrument. To hear this correctly, astronomers compare the same galaxy in several voices. Optical images show dust lanes and old starlight. Infrared mosaics reveal the hidden nurseries. Radio maps trace cold hydrogen, the raw material from which stars condense, and millimeter arrays like ALMA draw the contours of molecular gas, carbon monoxide acting as a lantern in the fog. Even mid-infrared spectra carry fingerprints, aromatic features from complex molecules, deep silicate absorption that testifies to thick blankets of dust. Together, these views turn a muted object into a choir. What looked like a faded oval becomes a workshop packed with embers. Not all veils are evenly woven. Sometimes dust lies in clumps, thick as charcoal near newborn clusters and thin elsewhere. Sometimes it drifts like gauze across an entire disk. The geometry matters. A single line of sight through a clump can extinguish the light from a cluster completely while the neighboring region looks clean. This patchwork introduces a bias, what astronomers call attenuation rather than pure extinction, because stars embedded in dust are dimmed more than those in front of it. The average color and brightness we measure depend on how stars and dust are mixed, not only on how much dust exists. Two galaxies with the same total dust can look very different. One might seem red and quiet, the other, tilted a little, might sparkle. There are galaxies where dust does more than muffle. In growing bulges and merging cores, a central black hole can begin to feed, and the region around it becomes a lamp. Dust near that lamp bakes to high temperatures and radiates strongly in mid-infrared. If the lamp shines hard enough, it can empty the room, driving winds that clear channels through the veil. Observers read this interplay in emission lines and color ratios, disentangling the portion of the score sung by stars from the portion sung by the active nucleus. In some systems, the nucleus dominates the heat. In others, star formation does. The veil is both consequence and participant, woven by past stars, warmed by present fire, pushed by central engines that decide whether silence will be temporary or prolonged. At the larger scale, dust acts like a ledger for time. Grains form in dying stars and supernovae, grow in dense clouds, shatter in shocks, and evaporate in the intense radiation fields of newborn clusters. A galaxy full of fine dust has been busy. Many stars have lived and died, many clouds have cycled. A galaxy devoid of dust is either deeply starved or very young, its furnaces not yet having had time to shed soot across the rooms. In this way, dust carries memory. Its presence tells us that stories have already unfolded. Its absence tells us that stories are waiting to begin or have been paused. There is a deeper quiet that belongs to distance and expansion, and dust partners with it. As galaxies recede with the stretching of space, their light reddens. Wavelengths once short enough to pierce dust become long, and those that were already long slip beyond the range of older cameras. In such cases, the veil is doubled. Dust in the galaxy blocks the remaining visible light, and the universe itself shifts the rest out of sight. Instruments built to listen in new colors turn that double silence back into song. Where no galaxies seem to stand, fields blossom with tiny red sparks when viewed in the infrared. Each spark, a system whose voice arrived tuned to a new key. What does all this sound like to those working the night shift? In one corner of a control room, an optical image shows a pale disk punctuated by shadows. In another, a longer wavelength image displays a warm glow right where the shadows lie. A scientist traces the two with a finger, saying softly to a colleague, "Look, where it looks empty, it is full." A third view arrives from a radio array, arcs of hydrogen curling like smoke. They talk quietly about how to combine the data, how to fit the spectral energy distribution so that the energy lost to dust in one band equals the energy found in another. It is bookkeeping for light, a careful balancing of accounts that turns absence into evidence. For listeners, the metaphor is close to home. We all carry veils of one kind or another, circumstances that thicken our air, perspectives that tilt the angle of what others can see. Silence is not always emptiness. Sometimes it is a voice in the wrong register, a song sung under cloud. When astronomers refuse to declare a quiet galaxy truly quiet before they have listened in other bands, they are practicing a generous skepticism we can borrow. Look twice, change instruments, stand at a different angle. The hidden may be humming, hidden. Even the sky's background carries the echo of these hidden songs. Across the whole dome, faint and uniform, lies a glow in the far infrared, the sum of countless dusty galaxies, each one too small to pick out alone at older sensitivities. This cosmic infrared background is a choir of muffled voices blended into one. It tells us that much of the universe's star formation took place behind veils. It says that what we see in visible light is only part of the ledger. The other part is written in warmth. Some veils are temporary. Milky plumes drift. Starburst cocoons thin as winds carve passages. Black hole-driven outflows rearrange the furniture. A galaxy that was once invisible in the optical can return, cleaned by its own weather. Others settle into long privacy, their dust replenished as fast as it clears, their nurseries always half hidden. In both cases, the label silent depends on the listener, not only on the source. A telescope with a colder heart will hear what a warmer one misses. A survey designed for faint, diffuse light will recover structures that a survey tuned for bright knots discards as sky. This is where patience becomes method. Observers stack many exposures to draw out extremely low surface brightness features that betray faint outer disks and tidal streams laced with dust. They code fields in the infrared to detect the glow of grains warm just enough to whisper. They pair emission from carbon monoxide with traces of star formation to estimate how efficiently gas turns into stars behind the veil. Each technique is an invitation to the same humility. Do not name a thing empty until you have asked it in more than one language. And through it all, the galaxies themselves continue, indifferent to our attempts to categorize their voices. Dust forms, drifts, warms, and cools. Stars are born and die behind curtains and on open stages. The universe rehearses its own piece, and we, in the back row, learn to recognize themes that recur. One theme is this. Silence often hides a very busy room. As the night thins toward morning, imagine 3 frames placed side by side on a desk. In the first, a spiral displays a seam of darkness down its spine, a clean cut drawn by dust. In the second, taken at longer wavelengths, that seam is a lamp, bright where the first was dim. In the third, at millimeter wavelengths, cold molecular gas winds around the core like a river, the reservoir from which the hidden stars are fed. Nothing has changed in the galaxy. Only the instrument has. Our understanding moves not because the sky does, but because we learn to listen differently, hold that feeling. The next step in our walk through quiet will turn from veils to limits, the ways the universe dims galaxies simply by being large and old, the way distance and expansion thin surface brightness until it slips below the floor of our detectors. There is a quiet that belongs not to dust, but to geometry and time. To approach it, we will talk about how brightness spreads, how horizons form, and how the faintest things are coaxed into view by persistence and cleverness. For now, let the dusty hush remind you that some of the richest rooms wear curtains, and that a soft glow in a different color can be a kind of revelation. The universe has many ways of quieting its galaxies. Some are hushed by storms within clusters, some by exhaustion, some by veils of dust. But there is another silence, one that does not come from processes inside galaxies at all. This is the silence imposed by distance, by geometry, and by time itself. Even the brightest choir sounds faint when it sings from far away. Even the clearest lamp dims when spread across distance. This is the cosmic hush that comes not from absence, but from the nature of light. Imagine you hold a lantern in a wide field at night. Near you, the glow is strong. Step back, and the glow thins. Step farther still, and the light that once lit the grass around your feet becomes only a speck against darkness. The lantern has not changed. Its fire is steady. What changes is the geometry. Light spreads out in all directions, its energy diluted across a growing sphere. The same principle governs galaxies. A system with billions of stars may be as luminous as the Milky Way. But across millions of light years, its surface brightness thins until it blends with the background sky. To the unaided eye, it is gone. To a telescope, it is a challenge. To our patience, it is an invitation. Astronomers face this challenge with equations as well as with awe. The surface brightness of a galaxy decreases with the square of distance, and the expansion of the universe makes the effect even harsher. Not only does light weaken as it spreads, but the stretching of space redshifts it into longer wavelengths, sometimes beyond the reach of detectors tuned to shorter light. Add to this the simple truth of time. Distant galaxies are seen as they were billions of years ago. Their photons have traveled across most of cosmic history to arrive at our instruments. On the way, the universe has expanded, dimming them further. Silence here is not the absence of light. It is the drowning of light in the vast pool of space. This effect shapes every deep image. The famous Hubble Deep Field, with its scatter of thousands of galaxies in a patch no larger than a grain of sand held at arm's length, is both a triumph and a reminder of silence. Each speck represents an island of stars, but for each visible, many more lie below the threshold. For every galaxy detected, there may be dozens whose light is too thin, too redshifted, or too diffuse to emerge from noise. We know they exist because models of structure formation predict them, because gravitational lensing hints at them, because the background glow of the sky demands their presence. But they remain whispers, unheard by our current ears. Astronomers call this challenge surface brightness dimming. It is one of the most frustrating and humbling truths in observational cosmology. A galaxy of fixed brightness appears fainter not only because of distance, but because its light is spread across more sky. The farther it is, the larger the apparent area over which its photons are distributed, and the more easily the signal is lost against noise. Imagine a voice calling across a canyon. Even if the words are clear at the source, by the time they reach the far wall, they are smeared into echoes, merged with wind. The galaxy's song becomes part of the cosmic murmur. Yet silence does not mean ignorance. Astronomers have invented ways to coax voices from faintness. They stack exposures, hundreds of hours of light collected from the same field, added together so that random noise cancels and steady signals emerge. They use adaptive optics to sharpen images blurred by Earth's atmosphere. They deploy space telescopes to avoid atmospheric glow altogether. Each technique is an act of patience, a refusal to let distance dictate silence. Slowly, galaxies at the edge of reach become visible. Some appear as tiny red smudges, others as arcs distorted by lensing. Their shapes may be vague, but their presence is undeniable. Consider the James Webb Space Telescope, now gazing into wavelengths once hidden. It has revealed galaxies from the universe's first few 100 million years, systems so faint and far that they were invisible before. Their light has been stretched by a factor of 10 or more, shifted into the infrared. To older eyes, they were silent. To Webb, they sing. They remind us that silence often belongs not to the object, but to the limitations of our instruments. What seems unreachable can be reached, given new ears. There is another kind of hush, the one imposed by the cosmic horizon. Because the universe expands, there are regions so distant that their light will never reach us. The expansion carries them away faster than photons can close the gap. These galaxies may exist, may thrive, may live full histories of star birth and death, but they are sealed off. Their silence is not temporary. It is eternal, imposed by the geometry of space-time. For every galaxy we can detect, there are others forever beyond. To think of this is to feel the edge of belonging. We live in a universe we cannot wholly see. Our cosmic family is larger than our census. Silence here is absolute, not because the galaxies do not speak, but because their voices can never cross the boundary. Philosophically, this silence is both humbling and comforting. It humbles us because it places limits on knowledge. No matter how advanced our telescopes become, no matter how clever our techniques, there will always be galaxies hidden beyond the horizon. It comforts us because it reminds us that mystery is permanent. The universe will never be fully catalogued, fully reduced to data. There will always be places left unseen, voices left unheard. Mystery is not a flaw of science, but its partner. Without it, curiosity would fade. With it, we are always invited to listen again. For listeners tonight, this truth is gentle. Just as not every memory can be retrieved, not every possibility can be realized, not every galaxy can be seen. That does not lessen their existence. It only changes our relationship. We belong not by possessing knowledge of everything, but by standing under the sky and accepting its vastness. Silence is part of the gift. Astronomers also find ways to use silence as evidence. The faint background glow in every infrared image, the statistical patterns in the cosmic microwave background, the distortions of galaxies behind clusters, all these are traces of what lies beneath hearing. Silence, measured carefully, becomes data. The unobserved becomes indirectly observed. Like footprints in snow without a traveler in sight, these hints prove presence without direct vision. Even galaxies too faint to name leave shadows in the background. Their hush is still a contribution. In this way, silence deepens science. It teaches that absence is not emptiness, but a clue. It reminds us that what we fail to hear directly may still shape what we do hear. Galaxies at the edge of detection influence the growth of structure, enrich the backgrounds, and remind us that the cosmos is more than we can contain. Silence is not failure, but invitation to patience, to humility, to imagination. As you drift deeper into thought, picture yourself lying on a quiet hillside at night, the Milky Way stretched above. To the eye it seems full, infinite. But beyond the edge of vision are galaxies unseen, voices unheard, silences profound. They are there, woven into the fabric, part of the same universe that holds you. Their hush is not emptiness, it is depth, and so our walk continues. We have heard how galaxies grow quiet from stripping, from exhaustion, from veils, from distance. Next, we will turn to silences even stranger. Galaxies whose quietness comes not from what is missing, but from the hidden substance that binds them. The dark matter that shapes their halos, present but invisible, powerful but mute. That is the mystery waiting ahead. When astronomers speak of galaxies, most people picture shining spirals or glowing ellipticals, luminous shapes painted across the night. But light is only part of the story. The deeper truth is that galaxies are built not from what we see, but from what we cannot. Stars, gas, and dust, the visible matter, are decorations compared to the invisible mass that binds them. This hidden scaffold is dark matter. It does not shine, does not absorb, does not scatter. It whispers only through gravity. And in its whisper, galaxies are shaped, held, and sometimes silenced. Dark matter halos surround every known galaxy. They extend far beyond the visible disk, vast spheres of unseen substance that outweigh stars by factors of 5 or more. Without these halos, galaxies could not exist in their current form. Stars would fly apart, unable to hold orbit. Spiral arms would dissolve, clusters would scatter. Dark matter is the stage on which the luminous performance occurs, yet the stage is quiet. It adds weight, defines structure, sculpts cosmic filaments, but does not shine. The greatest portion of a galaxy is mute. This silence matters most when we search for the faintest systems. Ultra-diffuse galaxies, sprawling disks as wide as the Milky Way, but with 1/100th of the stars, can exist because dark matter holds them together. Their stars are too sparse to bind themselves. Only the invisible halo makes them stable. To the eye, they are nearly absent, shadows more than shapes, like chalk, rubbed thin. But they are real, revealed through careful imaging and the motions of globular clusters within them. These galaxies are testimonies to silence, enormous, present, but whispering so faintly that without dark matter's quiet hand, they would never persist. Dark matter also hides in the voids. For every bright galaxy, simulations predict many dark ones, halos that never collected enough gas, or whose gas was heated and lost, or whose star formation was quenched before it began. These halos are the silent majority. They pull on neighbors, bend light, sculpt the web of large-scale structure, yet they never glow. Their voices are gravitational only. If you could drift through a cosmic void, you would feel their presence as invisible mountains, unseen but shaping your path. To our telescopes, they are mute. Their silence is profound, a reminder that the visible universe is only the tip of a deeper reality. Astronomers infer dark galaxies by indirect means. Gravitational lensing bends the light of more distant sources, revealing hidden mass. Motions of visible galaxies betray unseen neighbors tugging at them. The cosmic microwave background carries imprints of matter distributed in ways light alone cannot explain. Each of these is a translation of silence into evidence. Dark matter never speaks in photons, but its gravity is eloquent. We learn to listen differently, to hear the universe through curves and accelerations rather than glows. For listeners tonight, imagine a grand symphony where most instruments play in registers too low for the ear. You hear only a fraction, the violins and flutes of stars and gas. But the basses and drums, inaudible, carry the rhythm. They define the structure of the music, even if unrecognized. Dark matter is that foundation. It hums below hearing, steady, immense, without pause. Its silence is not emptiness, but strength. There is poetry in the fact that galaxies are built on silence. Their visible voices, spirals, bursts, clusters, are ornaments of a deeper architecture. We are drawn to the light, but the true backbone is quiet. Without the mute weight of halos, the luminous would disperse. This is a lesson for us as well. What is unseen often sustains what is seen. The quiet structures of our own lives, habits, relationships, patience, memory, are the halos that keep our luminous moments from scattering. Dark matter also teaches humility. For decades, astronomers struggled to explain why galaxies rotated faster than visible matter could support. Stars at the edges moved as if pulled by mass unseen. The solution was not an error in measurement, but the presence of invisible substance. In this way, silence corrected arrogance. We assumed light told the whole story. Gravity whispered otherwise. To live with that whisper is to admit that most of reality does not announce itself. There are galaxies that invert the usual ratio, systems apparently rich in stars but strangely poor in dark matter. Their rarity is debated, their nature mysterious. If they exist, they remind us that silence and voice come in many combinations. Some galaxies are almost all dark matter, with barely a spark of starlight. Others are nearly all starlight, fragile without their silent scaffolds. Between them lies the spectrum, and in that spectrum lies our ignorance and our curiosity. The cosmic web itself is a structure of dark matter. On the largest scales, galaxies align along filaments and walls sculpted by invisible mass. Where filaments intersect, clusters form, bright with galaxies, loud with collisions. Between filaments, voids open, vast regions with little light, but not empty, filled with the quiet gravity of halos that never kindled stars. To map the cosmic web is to map silence as well as sound. The luminous trace only the skeleton. The skeleton itself is dark. For us tonight, the silent galaxies of dark matter are invitations to rest in mystery. We will never see these halos directly. They cannot be photographed. But we can feel their presence in curves of starlight, in distortions of background galaxies, in the echo of the early universe. Their silence is permanent, and rather than frustrate, it comforts. It says that the universe does not reveal everything, that some truths are structural, not decorative. That silence itself is part of reality's song. As you let your breathing slow, picture a vast halo, invisible, surrounding a faint galaxy. Its stars are sparse, its disk ghostly. But the halo is strong, holding them together, protecting their fragile glow. Picture also the hidden galaxies in voids, dark shapes tugging but not shining. Picture the cosmic web, luminous filaments like frost outlining the unseen ice of dark matter beneath. This is the silence beneath all other silences. It is the foundation. And as we move onward, the next step will bring us back from the invisible scaffolds to the question of signals. Not all silence is structural. Some comes from voices we expected to hear, messages from beyond, signs of life that never arrive. The next chapter in our journey will be about the great silence of alien civilizations and what it means to live in a universe that may be crowded with worlds but quiet of voices. The silence of galaxies shaped by dark matter is deep, structural, and permanent. But there is another silence that touches us more personally. The silence of possible voices, the silence of civilizations we imagine but do not hear. For decades, astronomers have asked, if the universe is filled with stars, planets, and galaxies, where are the signals from other minds? Why, among billions of galaxies and trillions of worlds, do we not hear even a single greeting across the dark? This absence has been given a name, the Great Silence. Consider the scale. The Milky Way alone contains hundreds of billions of stars. Many of those stars host planets. Among them are worlds of rock and water, cousins to Earth, warmed at distances where life as we know it could flourish. Multiply this across galaxies, and the numbers become staggering. The probability of life elsewhere seems high. Civilizations should be common. And yet, as far as our antennas and telescopes reveal, the universe is mute. No signals, no evidence, no clear whisper from beyond. This silence is not accidental. Astronomers have been listening. Radio telescopes have swept the skies, searching for narrow-band signals that nature does not produce. They have stared at stars like the sun, at clusters where many stars gather, at regions rich in potential worlds. They have scanned millions of frequencies, hoping for a beacon. The result is nothing, not a single confirmed message. The sky hums with natural static, pulsars, quasars, the hiss of cosmic microwave background, but it carries no deliberate word. One explanation is distance. Signals weaken as they spread, diluted across spheres of ever-growing radius. A broadcast as strong as Earth's radio leakage becomes indistinguishable from noise after only a few light years. Civilizations might be speaking, but softly, and we are too far to hear. Another explanation is time. Civilizations may be brief, rising and falling across millennia too small compared to cosmic ages. Two may never overlap. One voice may fade before another begins. Across billions of years, the chance of alignment is slim. Some suggest that civilizations choose silence. Perhaps advanced societies turn inward, satisfied with their own worlds, uninterested in broadcasting across impossible gulfs. Or perhaps they recognize the risks of shouting into the dark, preferring safety in quiet. Silence, then, is not absence but caution. Others suggest darker outcomes, that civilizations burn out, consume themselves, or are erased by forces indifferent to their existence. In that view, silence is the graveyard of ambition. Philosophers treat the great silence as a mirror. It reflects our expectations, our fears, our hopes. When we listen and hear nothing, we project reasons, distance, timing, choice, fragility. Each reason reveals what we think about ourselves. Are we lonely because the cosmos is empty? Or because we are too impatient? Or because we ourselves are not yet ready to be heard? For us tonight, the great silence carries another meaning. It is a reminder that the universe is not obligated to satisfy curiosity quickly. Just as faint galaxies require patience, just as diffuse systems require new instruments, so might voices. To live with silence is to practice humility. We cannot demand answers on our schedule. We can only ask and wait. The waiting itself becomes meaningful. There is poetry in imagining the possibilities. Somewhere, perhaps, a civilization is pointing its own antenna outward, listening to its quiet sky. Somewhere, another is building telescopes to map galaxies and asking whether they are alone. Perhaps across unimaginable distances, countless listeners sit under alien stars, each waiting for the others. The silence we share may not be emptiness, but chorus. Many ears, no mouths, a universe of listeners overlapping in longing. Astronomers often point out that silence itself is data. The absence of signals constrains the number and behavior of civilizations. If the cosmos were loud, filled with powerful beacons, we would know. That it is quiet tells us something about probabilities, lifespans, and choices. Silence becomes evidence, even as it frustrates. Just as dark matter is known by what it pulls rather than what it shines, civilizations may be known by their silence as much as their voice. For those lying awake tonight, let the great silence feel less like loneliness and more like mystery. You are not denied company, you are invited to wonder. Each star overhead is a possibility unopened, each galaxy a library unread. Silence is not the end of story, only its pause. And in that pause, imagination blooms. Picture yourself under the Milky Way, radio dishes turned skyward beside you. The dishes look like giant ears, listening to frequencies the human body cannot hear. Above, the sky arcs with billions of stars, each a potential world. You listen, and the silence is vast, but not empty. It is charged, like the pause before a note begins, like the breath before speech. You are part of this listening. You are part of the cosmos, waiting for its next word. As we leave this reflection, we carry forward the truth that silence is layered. It can be structural, as with dark matter. It can be imposed by dust, distance, or exhaustion. And it can be chosen, or accidental, or temporary. The great silence of civilizations is perhaps the most poignant because it speaks to our longing for company. But longing itself is a form of connection. To wish for another voice is to belong already to the great chorus of listeners. Next, we will turn from this silence of absent voices to another subtle quiet. The silence of comets, those icy wanderers that sometimes carry the ingredients of life itself. What does it mean that fragments of rock and ice can deliver chemistry across galaxies? Can silence also carry seeds? That will be our path ahead. The silence of alien civilizations leaves us with questions that linger like echoes. But silence does not always arrive in the absence of life. Sometimes it is present in the small carriers of potential, in wanderers that speak not with voices, but with chemistry. Tonight, we turn to comets, icy travelers that slip through the dark, seemingly mute, but filled with possibilities. They are fragments of the early universe, remnants of star nurseries, couriers of water, carbon, and complex molecules. In their silence may rest the seeds of life itself. Imagine the birth of a solar system. A cloud of gas and dust collapses under gravity. In the center, a star ignites, and around it, a disk of material spins. Within that disk, particles collide and grow, forming planets, moons, asteroids, and comets. The comets form far from the star, in the cold reaches where ices can persist. They are frozen archives of the dawn, preserving ingredients unaltered for billions of years. While planets burn and churn, comets wait, quiet in the outskirts like unopened letters. Occasionally, gravity perturbs them. A passing star, a tug from a giant planet, a resonance in the outer regions. All can send a comet inward. It plunges toward the star, and as it warms, its ice sublimates into gas, releasing dust that forms a glowing tail. From Earth, we see a comet as a bright streak, a visitor lighting the sky. But beneath the beauty is chemistry, water vapor, carbon compounds, amino acids. These ingredients drift outward, carried by tails across space. To some worlds, they deliver water. To others, the raw material of biology. Astronomers suspect that Earth itself was seeded by comets. The oceans may be gifts from icy impacts. Molecules essential for DNA and proteins have been found in comet samples. One silent strike may have tilted the balance, turning a barren rock into a home for life. If true, then comets are not just visitors. They are messengers, crossing light years, carrying whispers of possibility. Their silence is not emptiness, it is potential waiting to be unlocked. Across galaxies, comets are everywhere. Every star system likely has them. Frozen reservoirs in Oort cloud-like shells, thousands of times farther than the outermost planets. These shells are invisible, too faint to detect directly, but theory and evidence demand their presence. Comets may drift between stars, ejected by gravity, wandering as interstellar messengers. Already, in our lifetime, we have seen two such objects pass through, Oumuamua in 2017 and Borisov in 2019. Visitors from beyond. They entered silently, curved through our solar system, and departed, leaving us to wonder what chemistry they carried. Their silence was brief, but profound. If comets carry seeds, then galaxies are gardens. Each system plants not only planets, but packets of possibility. Some packets never arrive anywhere. Others crash into barren ground. But a few land where conditions allow, and life sparks. Over cosmic time, comets may be agents of panspermia, the spreading of life across stars. The idea is speculative, but its poetry is irresistible. A universe filled with silent couriers drifting between galaxies, scattering chemistry like pollen. If true, the silence of comets is less an absence than a waiting chorus, singing softly in molecules rather than words. There is also danger in comets. Their silence can end as suddenly as it gives. Earth bears scars from impacts, craters, extinctions, resets of history. One strike is believed to have ended the age of dinosaurs, clearing the way for mammals to rise. In this sense, comets are both destroyers and creators. They silence species but open space for others. Their duality is part of their mystery. Fragile, ice, capable of reshaping entire worlds. Astronomers study comets not only for their beauty but for their archives. Each carries the record of conditions from billions of years ago. Missions like Rosetta, which orbited comet 67P Churyumov-Gerasimenko, revealed landscapes of cliffs, boulders, and jets of gas. The comet whispered through data, telling the story of early solar chemistry. Samples from missions like Stardust and Hayabusa brought back molecules older than Earth itself. To hold comet dust in a vial is to hold silence that predates humanity. For listeners tonight, comets offer a metaphor. Sometimes what seems small and quiet carries immense power. Sometimes silence is not the absence of speech, but the holding of a gift. A comet drifts unseen for billions of years, then arrives in a burst of brilliance, delivering water, molecules, and history. Our own lives contain such moments, long periods of quiet, followed by sudden arrivals that change everything. Comets remind us that silence can be full, fertile, and meaningful. As you breathe deeply, imagine a comet on its long arc. Far from its star, it is dark, indistinguishable from rock. As it falls inward, sunlight touches it, ice awakens, and a tail blossoms. From a world below, observers marvel at its sudden voice. But soon it drifts outward again, tail fading, returning to silence. This rhythm, quiet, song, quiet, is the rhythm of the cosmos. Galaxies themselves breathe in this way. So do we. And so, the silence of comets joins the choir of quiet galaxies. It is not absence, but patience. Not emptiness, but offering. The next step in our journey will look at another kind of silence, one hidden beneath oceans that never see light, the moons of distant planets, worlds whose surfaces may be frozen, but whose depths may whisper with secret seas. The silence of comets left us with a soft feeling of expectation, as if the universe were full of sealed letters waiting to be opened. Tonight, the hush grows deeper and closer. We leave the glare of stars and step into the darkness beneath ice. There are worlds in our own neighborhood that look frozen and still, worlds where the surface is locked in winter, the air thin or absent, the sunlight weak. But under those shells of ice, entire oceans sway, black, pressurized, salted, alive, with energy. They do not announce themselves with blue waves and whitecaps. They do not glitter in daylight. Their existence is a rumor carried by gravity and magnetism, by the chemistry of a plume, by the tiniest tilts in a moon's dance. These are the silent oceans, and they may be among the most promising places in the universe for life to take root. Begin with Europa, a small moon circling Jupiter, bright as a polished stone. Its surface is etched with rusty lines, fractures that mark where the ice has stretched and healed, where plates have shifted and frozen again. If you stood on that plain, nothing would move. The horizon would be a line of whiteness broken by ridges. The silence would feel complete. But the evidence says otherwise. Instruments carried by the Galileo spacecraft found a magnetic signature around Europa that behaves as if a conducting layer lies beneath the crust. Salt water conducts. An ocean, global in extent, seems to exist under kilometers of ice. Later, telescopes recorded hints of plumes, jets of water vapor rising from fissures, thin and transient, as if the moon were exhaling. Put these clues together and the picture forms: ice on top, liquid beneath, heat from tidal kneading, and perhaps from a rocky seafloor below, where water and stone meet in chemical conversation. Cross to Saturn and find Enceladus, smaller still, a pearl with a fracture-patterned south pole. There, the silence breaks into whispers we can measure. The Cassini spacecraft flew through fountains of vapor erupting from tiger-striped fissures. Inside those plumes, it detected water, salts, simple organics, and tiny grains that match minerals formed where hot water meets rock. It also found hydrogen, gas, an ingredient produced in hydrothermal reactions at a warm seafloor, reactions that feed microbes on Earth's oceanic ridges. Enceladus became a revelation, an ocean confirmed, a chemistry suggestive of energy gradients living cells can use an entire world ocean venting its secrets into space. If Europa's ocean is a rumor, Enceladus's is a confession. Ganymede adds another chapter. It is the only moon with a magnetic field of its own, and beneath its varied surface lies a stack of oceans and ice, like pages in a book. Some models suggest layers of salt water separated by high-pressure ices, with a rocky seafloor at the bottom. Callisto, older and more cratered, may hold a deep ocean as well. Titan, Saturn's giant, carries methane lakes on its surface that shine like black mirrors in the Arctic light, while below its crust evidence points to a water ocean mixed with ammonia. Farther out, Neptune's moon Triton appears to have once been an object like Pluto, captured and warmed into activity. Its surface frosts and geysers should not exist on a dead world, hinting at heat and perhaps liquid reservoirs within. The list of quiet oceans grows, and with it, the sense that an ocean under ice is not a rare exception, but a common outcome of planetary formation. What do these oceans have in common besides darkness? They have energy. On Europa and Enceladus, tidal forces flex the moons as they circle their giant planets. Imagine a rubber ball squeezed and released, over and over, warming from within. That heat keeps water liquid beneath the ice. Where water meets a rocky seabed, elements are leached, redox reactions operate, and hydrothermal vents can form, chimneys of minerals that release warm, chemical-rich flows. On Earth, life crowds near such vents even in the deepest blackness, feeding on chemistry rather than sunlight. A world does not need a sunlit surface to host metabolism. It needs liquid, energy, and time. They also have salt. The presence of salts in Enceladus's plume particles suggests that its ocean is not pure water, but a brine that circulates through rock. Salt lowers the freezing point, making liquid more stable. The ocean can remain fluid, even as the surface hardens into shell. On Europa, colored streaks on the surface may be salts lifted from below and altered by radiation. Chemistry travels upward, writes faint letters on the ice, and then sinks or is buried again by frost, a slow dialogue between ocean and surface written in whisper-thin layers. How do we know these things without dipping a cup? Gravity and magnetism speak. When a spacecraft flies past a moon, it feels the moon's pull. From tiny changes in speed, we infer the interior. A denser core, a watery layer that bulges with tides. A magnetometer measures the way a planet's magnetic field induces currents in a conductive ocean. The libration, the small wiggle in a moon's rotation, betrays whether the crust is locked to the core or floating on a liquid. Cameras show fresh cracks and chaos terrain, as if plates of ice have drifted and refrozen. Plume encounters offer direct sampling, grains and vapors striking detectors at high speed, leaving chemical fingerprints. Each measurement is a stethoscope, held to an icy chest. The heartbeat is faint but regular. In these silent oceans, life, if it exists, would not see stars. Imagine an organism near a vent on Europa's floor. Above is a roof of ice tens of kilometers thick. Beyond that, a sky it will never meet. The organism would know gradients of heat and chemistry, not dawn or dusk. It would navigate by currents, not constellations. Its senses would be tuned to minerals, pressure, and flow. On Earth, bacteria and archaea thrive in such environments. They metabolize hydrogen, sulfur, iron. They form mats and communities, feeding and being fed upon. If a similar ecology exists under ice elsewhere, it would be quiet in our terms, but vivid in its own. The silence, then, is relative. To us, these oceans are mute because they send no light. They are broken by rock and ice, sealed from starshine. To the inhabitants, microbial or otherwise, they might be roaring with chemical flavor, crowded with gradients, lush where warmth seeps. Silence here is a mismatch in language. We listen with eyes. These worlds speak in taste and touch. Why? Do these hidden seas matter when our topic is galaxies? Because the universe's promise does not only live in bright places. A galaxy can be dim and still carry immense mass. A moon can be dark and still hold an ocean. The choice to look under the shell is an attitude we keep returning to. Do not equate quiet with empty. The same patience that finds ultra-diffuse galaxies teaches us to examine faint tilts in a moon's gravity, to trust subtle magnetism, to follow a wisp of vapor through the night. Missions are being planned and launched to deepen the listening. A probe that orbits Europa will measure the thickness of ice, map the composition of the surface, and sniff for plumes with instruments sensitive to organic molecules. Another craft will tour the Jovian system, probing Ganymede's magnetic field, skimming past Europa and Callisto. Engineers imagine landers that could touch down on fractured plains and drill shallow holes, or even melt slowly downward with heated probes, sending fibers behind like breadcrumbs to keep communication open. Farther ahead are ideas for submersibles, robots designed to swim in darkness, to taste water directly, to feel hydrothermal vents, and bring back news. The pace is careful, the environment is harsh, but the promise is immense, to move from inference to contact. Even before a cup of water is lifted, the ethical questions gather. If life exists under the ice, how do we explore without harm? A single terrestrial microbe carried by a careless tool could colonize a niche or confuse a detection. The silence of the oceans is not only a scientific boundary, it is a moral one. We are learning to clean, to bake, to seal, to confirm, to treat these places as we would a sanctuary or a library. Curiosity is strong, so is restraint. The poetry of these oceans lives in their patience. For billions of years, under pressure and frost, they have persisted. Tidal rhythms pump them. Thermal gradients shape them. They have waited while on the surface of one small planet. Ours, eyes. Evolved, telescopes were built, and minds began to wonder about darkness. Now the rooms may be ready to receive guests. The thought is both intimate and vast. If an ocean under ice harbors life, then the universe is generous in a way we had only guessed. It builds habitats in places where starlight cannot go. Even if no cells swim under those roofs, the meaning is still rich. Oceans under ice teach us about stability, climate, geology, chemistry. They teach us to listen with instruments tuned to gravity and magnetism rather than to color. They teach patience as a method and humility as a stance. In that sense, their silence is already working on us. We adapt to hear it. Let your imagination step into that water for a moment. The pressure is immense. The temperature, near freezing except near vents where warmth blooms. Particles drift like snow. Far above, the ice roof creaks and settles, relaying the tides of a giant planet through low groans. A submersible glides, its lamps the only stars this ocean will ever see. In the beam, a chimney appears, minerals precipitating into filigree towers, plumes rising like breath. Chemistry dances. The vehicle inhales and analyzes, exhaling nothing into the water but photons that fade a few meters away. Silence returns as soon as the lamps are dimmed. We do not need to solve this place tonight. It is enough to have found language for it. Oceans that speak in salt and heat. Galaxies that speak in mass rather than radiance. Comets that deliver grammar to planets. Civilizations that might choose to listen rather than broadcast. The theme is consistent. The universe writes in many scripts, and our work is to learn to read them without insisting they be inked in the colors we prefer. From here, our path will arc outward and inward at once. Outward, because we will follow the oldest messages we have ever received. Thin radio waves from machines that have left the domain of planets and keep talking back. Proof that a voice can cross decades and remain faithful. Inward, because those messages will invite us to think about time, memory, and what it means to send a greeting into a future we will not see. The spacecraft that drift into interstellar space are small compared to moons and trivial compared to galaxies, but their persistence makes them kindred to quiet oceans. They speak slowly, they endure. In the next passage, we will listen to those travelers and to the way they keep their promise, to keep speaking across distance and age, while our own lives pass and new listeners take our place. For now, let the sound of deep water carry you toward rest. Think of Europa's fractures sealing with frost, of Enceladus's plumes rising and falling like a moon's breath, of Titan's black lakes and the rumor of warmth below. Think of a universe that hides its gentlest rooms under armor, not to deny us, but to ask us to come carefully and to listen well. The silence is not a wall, it is a door with a delicate hinge. From hidden oceans beneath icy crusts, let us drift now to something smaller and more fragile, machines of our own making. They are not stars, nor moons, nor galaxies. They are thin, metal messengers, each no larger than a small car, built with rivets and circuits rather than stone or fire. And yet, they may be among the most enduring voices our species has ever created. They are the Voyagers, spacecraft launched from Earth more than 40 years ago, now wandering into interstellar space, carrying with them greetings pressed into golden discs. In their silence and persistence, they embody the same patience as oceans and galaxies. The story begins in the late 1970s. Two spacecraft, Voyager 1 and Voyager 2, were sent outward to explore the outer planets. They carried instruments to photograph, to measure, to listen. They swept past Jupiter, Saturn, Uranus, and Neptune, sending back images that changed textbooks and imaginations. They showed us volcanic plumes on Io, the braided rings of Saturn, the storm-darkened clouds of Neptune. They turned distant worlds into places, not abstractions. And when their planetary tours ended, they kept going, momentum carrying them outward, away from the sun, toward the spaces between stars. Each Voyager carries a golden record. On it are encoded sounds and images, greetings in dozens of languages, the laughter of a child, the call of a whale, the hum of wind, the beat of rain, the notes of music from Bach to Chuck Berry. The record is protected in a case etched with instructions for any who might find it, how to play it, how to interpret its signals, how to locate its origin. The Voyagers carry not just instruments, but culture. They are bottles tossed into a cosmic ocean, carrying messages to shores we may never reach. The silence of the Voyagers is layered. They still whisper faint signals back to Earth, weaker than a watch battery, received by giant radio dishes of the Deep Space Network. These signals are steady tones, modulated with data about plasma, fields, and particles. The content is technical, but the meaning is larger. Persistence, endurance, communication across billions of kilometers. The voyagers continue to speak long after their makers have aged. Their voices are faint but real, yet we know this will not last forever. Their power comes from nuclear batteries, plutonium decaying into heat, heat converted into electricity. As the decades pass, the batteries weaken. Instruments are turned off one by one to save power. Cameras closed long ago. In a few more years, even the transmitter will go quiet. The spacecraft will drift on, but their connection will fade. They will become silent except for the golden records, spinning mute but intact, carrying their message without broadcast, waiting for another civilization to find them. Their silence will be different from galaxies, different from comets, but no less profound. The silence of something once connected, now exiled by distance and time. Think of what that silence means. A voyager drifting beyond the heliopause is no longer in the bubble of solar wind. It feels the plasma of interstellar space directly. Its instruments have tasted particles born in other stars. It has crossed a boundary no living thing has crossed. And though its voice will fade, its presence continues. It becomes a relic, a symbol, a monument adrift. If it encounters another star, it will do so silently, gliding past without notice. If another intelligence someday intercepts it, they may decode the record and hear the voices of Earth. They may learn of our existence long after our own world has changed. In this way, the silence of the voyagers is also a bridge. For us tonight, the voyagers carry a lesson about endurance. Built with 1970s technology, they have outlived many of their makers. They show that small creations can last longer than empires. They remind us that fragility and persistence are not opposites. Something delicate can still endure across cosmic distances. Their silence is not failure, but legacy. Imagine lying beneath a night sky, knowing that two small machines are out there, farther from the sun than any other human-made object. They are tiny compared to stars, invisible against galaxies, but their meaning is vast. They are proof that voices can travel, that silence can be answered, that even small gestures ripple into the future. The voyagers are our comets, carrying not water, but culture, not chemistry, but memory. They are the bottles we have thrown into the cosmic tide. Their path is endless. In 40,000 years, Voyager 1 will pass near another star. By then, Earth may be unrecognizable, humanity transformed or gone, and still, the record will carry greetings, etched in metal, immune to centuries. Silence will hold it safe. That silence is almost tender, a vault preserving our moment, a capsule carried by currents we do not control. So the story of the Voyagers is not only about machines, it is about time, about how messages can outlive messengers, about how silence can protect as well as erase. For every galaxy unseen, for every civilization unheard, there are also whispers we have chosen to send. We may not know who will listen, but we have spoken anyway. And in the act of speaking, even into silence, we affirm that we are here. As we prepare to move onward, let us rest in this thought. Silence is not always absence. Sometimes it is the space that preserves. The Voyagers teach us that to endure, one must accept becoming quiet. But in that quietness lies the chance of being remembered. Next, we will follow this theme of endurance further, turning to the very edge of the visible universe. What does it mean that beyond a certain distance we cannot see, cannot hear, cannot reach? What is the silence of horizons, and how does it shape our understanding of existence? That will be our step into the next night. When we last paused, two small machines were drifting outward, carrying our greetings on golden discs. The Voyagers feel like the gentlest threads we have ever cast into darkness. Tonight, we follow those threads as far as they can go, until they reach limits not of engineering, but of nature itself. There are boundaries in the cosmos that no spacecraft can cross in the sense of keeping a conversation going, limits that no telescope can see beyond with light, horizons that are not walls, but facts of geometry and time. The edges of visibility are not single lines. They are a family of curves laid across space-time. To walk to those edges in the mind is to learn a quieter definition of reach. Begin with the simplest picture. Light takes time. Every look outward is also a look backward. When you see the moon, you see it as it was moments ago. When you see a nearby star, you see years of delay. With galaxies, the delay becomes centuries, millennia, then millions and billions of years. The deep sky is a museum arranged by distance, each exhibit labeled not only by place, but by age. The farther you look, the younger the universe you see. If there is an edge to this kind of looking, it comes where looking farther would mean seeing a time before there were stars at all. There is indeed such an edge. After the hot beginning, the universe cooled enough for atoms to form. Before that, free electrons scattered light so efficiently that space was an opaque fog. When atoms condensed, the fog lifted and light could travel freely. A thin glow from that era still fills the sky in all directions, stretched into microwaves by the expansion of space. It is the oldest light we can see with eyes made of antennas, a baby picture of the universe, imprinted when no galaxies had formed. Look past that, and there is no starlight to read, no glow that can reach us as photons through the fog. In this sense, the edge is a surface of last scattering, a shell surrounding us from which the earliest light arrives. Beyond it lies a time we can only study indirectly, through particles and waves that barely talk to matter at all. But even within the domain of light, there are subtler edges. The expansion of the universe stretches wavelengths and thins brightness. Distant galaxies become redder and fainter, their surfaces dimming until they slide under the floor of our instruments. This is not a failure of curiosity, it is a property of a universe where space itself grows. The more the light's path is lengthened, the more its color slips to ranges our older eyes could not hear, and the more its energy is diluted across the sky. Horizons bloom not as cliffs, but as gradients, the way dawn fades into day. Past some distance, light that was once vivid has become so stretched and thinned that practical detection is a matter of enormous patience and better ears. There is also a horizon that belongs to the future. The expansion of space appears to be accelerating, driven by something we call dark energy. Because of this acceleration, there are regions rushing away so quickly that no signal we send now will ever reach them. The same is true in reverse. Light leaving those places now will never arrive for us to catch. This is not because the light is slow, it is because the space between us and that light grows faster than light can close. Imagine two boats drifting, apart as a river widens between them, not from their paddling, but from the current's change. Even a perfect shout loses to a current like that. The cosmos contains an event horizon of this kind, a boundary that turns potential conversation into permanent silence. Hearing these edges described can sound like loss, but they carry their own form of comfort. They mean there will always be mystery. There will always be more universe than can be gathered into any archive. Knowledge does not end because questions remain beyond it. Knowledge becomes a way of living with those questions, placing instruments where they do the most good, learning languages that translate silence into evidence, honoring limits without resenting them. Even at the edge, whispers arrive. The ancient microwave glow is one such whisper. Not a picture of galaxies, but a map of tiny ripples in temperature and density out of which galaxies grew. There are fainter, harder whispers too. A background of neutrinos should exist, relic, particles from the first seconds, ghostly travelers that pass through stars and planets with scarcely a touch. A background of primordial gravitational waves, ripples in space-time from the universe's earliest trembling, may be imprinted in patterns we can someday read. These whispers do not carry images as photographs do. They carry imprints, fingerprints, that let us infer what sight cannot show. Beyond the visible edge, there is still a way to listen. Consider the look back we achieve already. Fields that once looked empty now blossom when observed in longer wavelengths by colder, sharper eyes. The earliest small galaxies, their light stretched far into the infrared, appear as tiny red embers. Gravitational lensing, mass-bending light like a glass of space-time, magnifies neighbors that would otherwise be too faint. In this way, the universe helps us overreach, curving paths of photons into our open hands. The edge, in practice, is not a fixed fence, but a moving line, retreating as we learn to see differently. What was once unreachable becomes a little less so, not because the universe changed its mind, but because we taught our instruments new songs. There is another horizon, more personal, that lies not in distance, but in time. Imagine the far future. Galaxies beyond our local group will drift out of sight. If acceleration continues, their light will fade beyond detectability, and the sky will grow emptier to any astronomer who lives then. The archives will still hold proofs of a wider cosmos, but direct evidence will be scarce. In that era, even the microwave glow will be stretched until it dissolves into quiet. The universe will still be there, but it will wear a veil that cannot be lifted by any method that relies on light. Our moment is privileged not by specialness, but by timing. We live at a distance from the beginning that lets us see both the birth sky and the blossoming of galaxies. We inherit a wide view briefly, and then it narrows again. To know this is to feel gratitude sharpen into attention. Edges teach method. They tell observers to accumulate time on target, to stack exposures, to place telescopes above the atmosphere, to chill detectors until they can hear a photon as faint as a snowflake landing on a leaf. They tell theorists to build models that respect horizons, to be precise about what can be inferred and what must be assumed. They tell storytellers to explain that beyond some shells of time and space, we do not know, and that this is not a failure, but a feature of a universe where causality and speed limit carry meaning. Edges teach ethics as well. Because visibility is finite, every dataset is a treasure. The faintest smudges in a deep field, the careful maps of microwave ripples, the meticulous records of passing neutrinos, each is a once-only gift. Reproducibility matters, archiving matters, openness matters, because a rare window deserves to be held in common. In this way, horizons become a civics lesson. What is scarce should be cared for together. For the listener tonight, horizons offer a more intimate parable. In life, there are experiences you cannot see into, no matter how much you wish to. There are futures from which no message returns. There are pasts hidden behind fogs of memory. You can resent these facts, or you can let them define a spaciousness, in which patience becomes a kind of wisdom. The sky shows us how to do the second. It teaches us to keep watch where watching is fruitful, to accept that some silences are structural, and to find meaning in the act of listening anyway. Return for a moment to the voyagers. Their signals fade as their batteries cool. Soon, they will cross from our speaking horizon into a silence that only their metal records can outlast. They will not complain. They will not know that the line was crossed. A horizon has that quality. It belongs as much to the one who listens as to the one who travels. If another intelligence finds a voyager far away and long from now, the record will jump the horizon in a different way, carrying news across time rather than across a radio link. The message will be simple. Someone looked up and cared. Now, let your mind step outward to the largest horizon, the one that separates everything we might ever see from everything we never will. On one side is a universe already more generous than we can fully inventory. On the other is a universe that exists without any chance of being confirmed by us. It is a comfort to imagine that generosity applies on both sides. Mystery does not end at the edge. It continues, unobserved by us, untroubled by our absence. The cosmos is allowed to be larger than our story. Somehow, that permission makes the part we can witness more radiant. Edges do not only deny, they also shape. Because there is a particle horizon, there is a shared origin for the light that fills the sky. Because there is an event horizon, there is a sense of a cosmic neighborhood we can influence and be influenced by. We are not everywhere. We are somewhere. And that somewhere, bounded but vast, is enough for a life of inquiry. In the seasons ahead for our series, we will keep returning to this dance between what is seen and what is inferred. We will turn from the farthest limits back toward places where new stars light up darkness, the nurseries where gas collapses into fire, the clouds that fold and unfold like slow-breathing animals. If horizons teach patience, nurseries teach beginnings. After walking to the edge tonight, we will step back into the room where the next generation of light is being born. Before we go, linger with 3 images. First, a globe of sky painted not with constellations, but with faint temperature ripples, the oldest light whispering about what would become galaxies. Second, an arc of a distant galaxy stretched by gravity into a curve, a kindness from space-time that lets us see further. Third, a line on a diagram representing the event horizon in a future where the sky grows quiet. A reminder that even the most generous views are mortal in time. These are not causes for sadness. They are reasons to become better listeners while the choir is near. Breathe with the sky. Allow the idea of a horizon to feel like a shoreline, not a fence, but a place where one kind of seeing ends and another begins. Tomorrow we will wade into the clouds where stars are born. Tonight we rest, on the edge, grateful for the view, quiet in the knowledge that there is more beyond than any book could hold. From horizons where vision fades, let us turn inward again to places where silence breaks into song. The galaxies that appear quiet are not always finished. Some hold within them nurseries where clouds of gas collapse into new light. To step into such a nursery is to watch silence transform into voice, emptiness into brilliance. In the deep darkness between stars, whole generations of suns are born. Their beginnings are slow, hushed and hidden, but their results shape galaxies for billions of years. A star nursery begins as a cold cloud of gas and dust. These regions are vast, stretching for hundreds of light years. Their densities low, but their mass is immense. To the eye through a telescope, they appear as dark patches blotting out starlight, or as luminous nebulae glowing in soft pinks and purples. The Orion Nebula is one such nursery, visible even to small instruments, a place where hundreds of stars are being born. Within these clouds, small fluctuations in density grow under the pull of gravity. Where the pull is strong enough, collapse begins and silence begins to crack. At first, the forming star is hidden. Dust absorbs the light, and only infrared telescopes can see the warmth of collapse. As gas flows inward, the center heats, the pressure rises, and a protostar emerges. Jets burst from its poles, thin streams of matter carving channels through the surrounding cloud. These jets are faint compared to full starlight, but they are the first sign of a new voice. Around the young star, disks of gas and dust swirl, reservoir from which planets may form. In this moment, silence gives way to promise. Clusters often form together. A single giant cloud may birth hundreds or thousands of stars. Some are small, destined to glow dimly for trillions of years. Others are massive, fated to burn bright and brief, exploding into supernovae that stir the cloud again. The mix of voices ensures diversity. Where once there was only cold gas, now there is a choir, a range of notes, some quiet, some thunderous, all contributing to the galaxy's ongoing story. The silence of nurseries is deceptive. To human eyes, they appear still. But radio telescopes reveal turbulence within, gas moving at tens of kilometers per second, magnetic fields twisting, molecules colliding. Chemical richness fills the clouds, water vapor, formaldehyde, methanol, even precursors to amino acids. The silence is alive with complexity. We do not hear it because our senses are tuned to light in narrow bands. With other instruments, the hush becomes symphony. Nurseries are fragile. The very stars they create destroy them. Radiation from young hot stars ionizes gas, carving bubbles of plasma that expand and sweep the cloud. Supernovae explode, blowing holes and compressing edges. Some regions collapse into new stars, others disperse into interstellar space. The nursery is both cradle and grave, building and dismantling at once. Its silence is temporary, its song, brief but generative. On a galactic scale, nurseries are engines. Spiral arms glow because waves of density compress gas and trigger new star formation. Starburst galaxies blaze when collisions compress vast amounts of gas at once, igniting furious starbirth. The balance between silence and voice shapes the life of galaxies. When gas is abundant, nurseries thrive and galaxies sing. When gas is depleted, nurseries fade and galaxies quiet. The rhythm of silence and song is the rhythm of cosmic evolution. For us tonight, nurseries offer a lesson in patience. Their stars take millions of years to form, far longer than a human life, yet short in cosmic terms. The silence we perceive is only because we are listening on the wrong scale. What seems still is changing. What seems hushed is busy. The universe reminds us again that quietness is not emptiness. It is a tempo slower than our own. Picture yourself inside a nursery. Dust surrounds you, thick as fog, blocking starlight. In infrared, you see protostars glowing faintly, their disks spinning. Jets of matter carve luminous lines through the haze. Beyond, massive newborn stars ionize their surroundings, sculpting pillars and ridges, shapes like cathedrals. The silence is not true silence. It is the sound of beginnings too slow for your ears. To lie in such a place is to feel the weight of possibility pressing from all directions. Astronomers capture nurseries in images that have become iconic. The pillars of creation in the Eagle Nebula show towering columns of gas, each harboring embryos of stars. The Horsehead Nebula shows a dark silhouette against a glowing background, a cold cloud waiting to ignite. These are not just pictures, they are portraits of silence in transition. To gaze at them is to watch the universe rehearse for brilliance. The silence of galaxies is never final while nurseries remain. Even in clusters of old stars, new gas can collect, sometimes from mergers, sometimes from streams along cosmic filaments. The cycle restarts, voice returns. A galaxy thought to be hushed can sing again. This rhythm, quiet, song, quiet, is not only the rhythm of comets and oceans, but of galaxies themselves. For listeners tonight, star nurseries are comfort. They show that silence does not always mean ending. It can mean waiting. It can mean preparation. It can mean gestation, the pause before a note begins. The clouds remind us that beginnings often hide under veils, that seeds take time, that silence may be fullness held in reserve. As we close this reflection, hold the image of a nursery glowing faintly in the dark, stars stirring within, dust scattering light into colors unseen. The hush of galaxies is not uniform. In some corners, the quiet is already cracking into song. In the next step of our journey, we will follow those songs further, tracing the threads that bind galaxies into webs, the great structures that connect the cosmos across unimaginable distances. From the silence of clouds, we move to the silence of scaffolds, the cosmic web itself. From the nurseries of stars, where silence turns to music, let us step back once more to the widest scales. Galaxies themselves are not isolated. They live in clusters and groups, and those clusters connect into filaments stretched across billions of light years. Between filaments lie vast voids, regions so empty of light they seem like cosmic deserts. Together, these filaments and voids form a structure known as the cosmic web. It is the skeleton of the universe, the architecture shaped by gravity and dark matter. And though it holds everything we see, the web itself is silent. It speaks through arrangement, not through light. The cosmic web is not drawn like a spider's threads, though the resemblance is strong. It is made of filaments where galaxies gather, walls where clusters align, nodes where superclusters sit, and voids where almost nothing shines. Imagine foam on water, bubbles pressed together, edges defined by films. The universe at large is like that foam. Galaxies light up the edges, but the real weight is in the unseen scaffolding that outlines the shapes. How did this web form? In the earliest universe, tiny ripples in density, fluctuations in the otherwise uniform soup, grew under gravity. Denser regions pulled more matter, becoming seeds. Over billions of years, the seeds stretched into filaments as matter fell along invisible lines. Gas followed dark matter's lead, galaxies lit up in knots, and the pattern became a vast lattice. Computer simulations trace this process, showing threads of dark matter spanning across cubic volumes of space, with galaxies lighting up where threads cross. What we see through telescopes matches what those simulations predict, a web-like pattern that extends farther than imagination. The silence of the web comes from its scale. We do not hear it because it changes slowly, across timescales far longer than human history. Filaments shift, but only over billions of years. Clusters merge, but at speeds that make continents seem restless. From our perspective, the web is frozen, a still photograph. Yet the photograph is alive in slow motion, its silence filled with movement too grand for our ears. Astronomers detect the web not only by mapping galaxies, but also by tracing intergalactic gas. Quasars, distant beacons, powered by black holes, shine through intervening space. Their light carries absorption lines, fingerprints of gas clouds along the way. By collecting many such spectra, astronomers reconstruct filaments invisible to direct sight. Radio telescopes detect faint emissions of hydrogen stretched across space, tracing rivers of matter between clusters. Each detection is a fragment, and together they outline the bones of the web. The voids between filaments are equally important. They are not truly empty, but their density is so low that few galaxies form within them. To drift through a void would be to travel for hundreds of millions of light years without encountering another bright system. The silence there is profound, and yet even voids carry whispers. Thin gases, rare dwarf galaxies, subtle gravitational effects. Their hush is as much a part of the cosmic balance as the glowing clusters. Without voids, the contrast of filaments would not exist. Silence and sound define each other. For listeners tonight, the web is a metaphor for connection. Each galaxy is like a city along a road. Alone, it glows, but its place in the pattern matters more. The roads themselves, the filaments, are unseen, but essential. They bind the cities into networks. In our own lives, connections are often invisible too. The habits, relationships, and histories that hold us in place. The cosmic web reminds us that silence can be the structure behind sound, the invisible pattern that makes the luminous meaningful. The web also humbles. Its scale dwarfs even clusters. When you see a map of the cosmic web, you are looking at billions of light years across. Each dot is a galaxy. Each thread contains millions of suns. Our own Milky Way is one speck on one strand, in one section of the lattice. And beyond the map, more filaments extend. The web is not bounded by imagination, only by the edge of what light has reached us. The silence of its immensity is overwhelming. To sit under the night sky, knowing that the true structure looks like foam stretched across infinity, is to feel both small and connected. In deep time, the web itself will change. As dark energy drives expansion, filaments will stretch. Galaxies, bound by gravity, will remain close, but distant filaments will drift apart, breaking the pattern we now see. In the far future, the cosmic web will thin, its strands receding beyond horizons. Silence will deepen, not because the web is gone, but because its shape will no longer be visible to any who remain. Our moment, then, is special. We live in a time when the web can be mapped, when its silent structure can be glimpsed. To listen now is to take part in a rare window. Astronomers speak of cosmic noon, the era when star formation was at its peak. That era was also when filaments were most active, feeding galaxies with streams of gas. The web was not just scaffolding but a river network, flowing matter into galaxies that lit up with newborn stars. The silence of filaments carried nourishment, invisible highways delivering fuel. Without those silent rivers, the galaxies would have starved. For us tonight, the lesson is clear. Silence can carry. Just as comets deliver molecules, just as oceans under ice may carry energy, so too the cosmic web delivers matter. Not all couriers announce themselves. Some walk quietly. The universe thrives on such silence. Imagine drifting outside all galaxies, far enough that you can see the lattice from above. Threads stretch in every direction, glowing faintly with clusters at their intersections. Between them lie vast black voids. The scale is beyond comprehension, but the pattern is delicate, like frost on glass. It is quiet, but not empty. It is the architecture of all that shines. And so, as we leave the web tonight, we prepare to step into another mystery, the silence of coldness. In the sky lies a region, a great cold spot, where the cosmic microwave background is fainter, cooler than its surroundings. Some think it is chance, others think it is the mark of a vast void, larger than any seen. Whatever its cause, it is another hush written across the heavens. That will be our next journey. From the lattice of the cosmic web, where filaments thread galaxies across billions of light years, let us pivot to something subtler. A hush imprinted on the oldest light we can see. Imagine the sky not as constellations, but as a map of ancient warmth. A portrait of the universe when it was a newborn, wrapped in a glow that has been traveling ever since. Across that portrait, the colors vary by the smallest amounts, tiny ripples that foretold where structure would grow. And then, in one region, the paint sinks as if a thumb pressed into wet plaster, leaving a broad, cool depression. Astronomers call it the cold spot, and while the rest of the picture makes sense, this bruise resists easy explanation. To understand why the cold spot matters, we need the canvas. After the hot beginning, the universe expanded and cooled until free electrons were captured by protons and helium nuclei to form neutral atoms. In that moment, light no longer bounced from charged particles. It streamed out in straight paths, filling space with a uniform glow. As the universe swelled and ages passed, that glow stretched into microwaves. We see it now as the cosmic microwave background, a shell of ancient light surrounding us from every direction. It is the oldest image of the cosmos we possess. This image is not perfectly smooth. It is mottled with differences in temperature measured in microkelvins, small variations that trace tiny overdensities and underdensities in the early universe. Those ripples grew into the web of filaments and clusters we mapped last night. Most of the mottling looks like what a simple theory predicts, a random field sculpted by primordial physics. But the cold spot does not look entirely typical. It is larger and cooler than one would expect by chance. Not an impossibility, perhaps, but a puzzle that invites questions. One family of answers lives close to home in cosmic terms. Light traveling across the later universe passes through regions that are not uniform, clusters, filaments, and voids. These structures have gravity, and gravity changes the energy of photons in subtle ways. When the cosmic expansion accelerates, potential wells and hills evolve as photons pass through them. This process, called the integrated Sachs-Wolf effect, can imprint slight coolings or warmings on the background light. If a photon crosses an enormous underdense region, a supervoid, the changing potential can drain a bit of its energy, leaving a cooler patch in the sky. Some surveys have indeed found a vast underdensity roughly in the direction of the cold spot, a swath of space with fewer galaxies than average. It feels tempting to say, there is the culprit, but temptations in science are invitations to caution. Calculations suggest that a void of plausible size can produce some cooling, though perhaps not enough to explain the entire depression. The underdensity helps, but the bruise may still be deeper than that alone can make. Others have searched for multiple nested voids that could add their effects, like a stack of thin filters. The sum may still fall short. If so, either our understanding of these late-time imprints needs refinement, or the cold spot points to an origin earlier than galaxies and voids. Another family of answers looks far back, beyond the growth of structure, toward the first seconds. In those early instants, the fabric of the universe may have undergone phase transitions, the way water freezes into ice. If defects formed in that process, cosmic textures for example, they could leave distinct, localized features in the microwave background. A texture passing through the line of sight could produce a single cold or warm spot, unlike the random ripples elsewhere. The statistics of the cold spot, its shape and surroundings, have been weighed against this idea. The verdict is not unanimous. Some studies find the texture hypothesis plausible. Others find the signature too gentle for a definitive claim. There is also the prosaic possibility of a statistical fluke. In any random field, unlikely patches appear simply because there are so many places to look. The cold spot might be such an accident, notable because we are the ones looking, rare but not impossible. This is the least romantic answer and the most resilient, the explanation that survives when others falter. It invites humility. Sometimes the universe offers a coin toss that lands oddly, and nothing more needs to be said. Beyond these, there are ideas at the borderlands of speculation. If our universe once brushed against another, if separate cosmic bubbles ever grazed in the inflationary past, such a collision could leave an imprint, a circular scar, a shift in temperature. The cold spot has been compared to such a footprint. The evidence is thin and the implications enormous. To take such a step requires more than a suggestive bruise. It requires a chorus of signs, and those are not present. Still, the human mind wanders toward doors that open onto larger rooms, and wonders whether the paint on the oldest picture hides an earlier wall. We have not even spoken about foregrounds and instruments. Before any conclusion is drawn, the map of the microwave sky must be cleaned of emissions from our own galaxy. Dust that glows at long wavelengths, charged particles spiraling in magnetic fields, haze from the solar system. Different satellites, using different methods, have produced consistent images of the cold spot, which gives confidence that it is not an artifact. But the caution remains. Subtracting foregrounds is an art as well as a science. One must constantly ask whether a quiet patch is the sky speaking, or our cleaning whispering. If this all sounds like a tangle of maybes, that is because it is. The cold spot sits at the intersection of statistics, astrophysics, and the earliest physics we can hope to test. In such borderlands, certainty is shy. The proper posture is patient attention. More surveys of galaxies refine the map of voids and walls. Better measurements of polarization in the microwave background improve our ability to distinguish primordial signals from late-time imprints. Cross-checks between different instruments and methods, year after year, turn a single oddity into a better framed question. For listeners tonight, the cold spot offers a special kind of peace. It is a mystery woven into a sky that is otherwise astonishingly well understood. The background light validates elegant theories with exquisite precision, and within that triumph lies one bruise that does not quite fit. That is an honest portrait of inquiry, clarity with one cloud drifting across it. We do not require the cloud to cover the whole sky to be meaningful. It is enough that it invites us to keep looking. There is poetry in the nickname itself, a cold spot in an image. Only microkelvins from smooth would be invisible to the senses. But to instruments with long patience, it stands out. It is quiet in two ways at once, cooler than its surroundings, and expressed only to those who listen in the language of microwaves. The universe seems to favor such layered silences. Oceans hidden under ice, galaxies spread too thin for casual sight, halos without light, and now a hush pressed into the oldest glow. Imagine, if you like, standing under a perfect night, holding the idea of the cold spot in your mind's eye. You cannot point to it with a finger. You cannot see it with human vision, and still, it hangs above, a feature as real as any star, real because a long chain of care has revealed it. Telescopes gathered photons, algorithms sifted noise, maps were cross-checked, and a patient, shared belief emerged. Something there is different. The trust rests not in a single instrument, but in the community that listens and compares notes. In that sense, the cold spot is not only a feature of the sky, but a feature of collaboration. Whatever its cause, the cold spot folds the themes of our journey back upon themselves. If a supervoid contributes, we are reminded that the web's empty spaces have power. If a texture is responsible, the earliest moments have left more than a statistical whisper. If it is a fluke, then even randomness paints with character. In every case, the lesson is the same. Silence deserves attention. A small, cool hush can carry more wonder than a blaze of obvious light. Practical work continues. Astronomers design surveys that look for voids with sharper tools, assemble catalogues to test alignments with the cold patch, and refine theories of how evolving gravitational potentials tint passing photons. Others pursue independent attacks, maps of microwave polarization, searches for subtle non-Gaussian patterns, cross-correlations with radio and infrared backgrounds. Each path is a new ear pressed gently against the same wall. The sound is faint, but shared listening amplifies trust. For those drifting towards sleep, let the cold spot be a lullaby of restraint. Not all questions demand a grand answer. Some ask for companionship. Stay with me a while, and in staying you will become the kind of mind that can live with wonder. The sky's oldest picture holds within it one small uncertainty, and this feels exactly right for beings who are themselves small, short-lived, and curious. We do not dominate this portrait. We visit it, learn from it, and leave it for those who come after, who will listen again with new instruments and gentler hands. As our story continues, we will keep the cold spot in peripheral vision, a quiet landmark. Ahead lies another riddle of presence and absence. Reports of systems that seem too massive, too early, or simply out of place in the timeline drawn by our best models. A galaxy that should not be there, announced by light that crossed almost the entire age of the universe to reach us. If a bruise on the oldest glow invites humility, a misplaced galaxy invites renovation. The next steps will take us from a hush painted on the background to a shout from the frontier, and we will ask how both can be true at once. The cold spot whispered of something unusual, a hush impressed on the earliest light. Tonight, we close this journey with another enigma, galaxies that seem to stand where none should. They are bright and massive, shining from an era so young that theory hesitates. Their very presence appears to break the rhythm we thought we understood. And while the cold spot asked us to notice an absence, these galaxies ask us to face an unexpected presence. Together they remind us that the universe is not obliged to fit neatly into human models, and that surprise is its most faithful language. The puzzle began when deep surveys pushed further into the infrared, peering back toward the first few 100 million years after the hot beginning. In those early times, matter was still settling, gas cooling, stars igniting for the first time. According to our models, galaxies should have been small, irregular, faint, a scatter of first attempts, like sparks before a fire takes hold. But some of the galaxies we see are large, luminous, even well-formed. Their light has traveled for more than 13 billion years, yet it arrives carrying the signature of maturity. They seem to have built themselves in a fraction of the time we expected. Astronomers debate what this means. One answer is that our models of star formation and growth are incomplete. Perhaps gas cools more efficiently under some conditions, or feedback from early stars and black holes shaped growth differently than we imagined. Another answer is that our measurements need refinement, that distances, masses, or ages are not quite what they seem. New instruments clarify, but each round of data keeps at least some tension alive. The fact remains, galaxies appear where the timeline said there should only be seedlings. The silence here is not in what is missing, but in the inability of our equations to speak fluently about what is seen. When models fall quiet, the sky itself must guide. That is humbling and healthy. Theories serve observation, not the other way around. The presence of impossible galaxies is a reminder that nature writes more richly than chalkboards. Some speculate that dark matter again plays a role, scaffolding structures faster than expected. Others look to the physics of the early universe, inflation, dark energy, or interactions beyond known particles. Still others point to chance, to rare systems, that though unusual are not impossible. Whatever the ultimate resolution, the lesson is the same. Even in a universe mapped with care, surprises bloom. For us tonight, the thought of galaxies that should not exist is oddly comforting. It means that even after decades of observation, after satellites mapping backgrounds and telescopes piercing darkness, the cosmos can still astonish. That astonishment is not an error. It is an invitation. Each anomaly is a doorway. Each puzzle is a chance to expand not only science, but imagination. Imagine lying back and picturing one of these galaxies. It gleams faintly red, its light stretched by expansion, but its mass rivals giants. Around it swirl clusters of stars, some already old compared to the universe's youth. Gas streams into its core, feeding bursts of formation. To any eye watching at that time, it would have looked like a beacon ignited too soon. And yet here it is, its light arriving at our instruments across ages. Its very existence is a kind of music played early, played loudly, against expectations. This final silence of our story, then, is not really silence at all. It is the quiet humility we feel when we realize our knowledge is provisional. That humility is a gift. It says that even the grandest maps are drafts. Even the most confident predictions may be corrected by a single distant smudge. The cosmos keeps us honest, not by withholding, but by surprising. As we close this chapter of Galaxies Beyond Reach, let us pause and gather the themes. We walked through silences shaped by stripping, exhaustion, dust, distance, horizons, and dark matter. We listened for voices of civilizations and heard only quiet. We watched comets carry chemistry, oceans breathe under ice, spacecraft drift outward, and nurseries kindle stars. We traced the cosmic web, felt the cool bruise of the cold spot, and now witnessed galaxies that should not be. Each silence was different, but all were full. For you listening tonight, thank you. Your attention is the most precious resource, and I am deeply grateful you have given it to this journey. If you have felt even a moment of calm or a spark of wonder, then this time together has been worthwhile. This series continues with new mysteries each week, and your support, through a gentle click to subscribe or a quiet like, means more than you can know. It is not only encouragement, it is the fuel that keeps these voyages possible. The way dark matter sustains galaxies, or quiet oceans sustain hidden worlds. As you drift towards sleep, carry with you the thought that the universe is not finished surprising us. What seems silent may whisper tomorrow. What seems impossible may simply be unexplained. And what seems unreachable may one day be touched by patience. The galaxies beyond reach are not beyond imagination. They are within us now, part of the shared story we tell as we look up. Rest in that story. Let it soften your breathing, slow your thoughts, and cradle you in wonder. The night is wide, and silence is generous. Tomorrow will bring new questions, and we will be here again, listening, together.